Hola amigos, bienvenidos a un nuevo episodio de CoreDevX LabsTV, el programa de YouTube donde analizamos las tendencias actuales de tecnología e innovación. Hoy nos encontramos con un gran amigo, alguien que trabaja en una industria súper interesante, que es la industria del entretenimiento. Le damos la bienvenida a David. Hello David, welcome to the show.
Hola amigos. That's all the Spanish I know, so hopefully you said something nice about me. Nice to see you, Andres. You too, Steve.
Yeah. Well, hola Felipe, how are you? How's everything in the South?
Hello. Welcome, David. Thank you for your time. David is in Paris, Andres is in Santiago, and I'm here in Pucón. It's a great pleasure to have you here, David. What do you think if we start this amazing conversation today?
David is an executive at Walt Disney Imagineering. So what is an Imagineering? So kind of like there's two words there. You imagine things, but you're an engineer as well?
Very smart, Andres. You've got it exactly right. In fact, Imagineering is a made-up word. It's a word that was actually invented by Walt Disney himself. When he started our company back in the 1950s, he had this great idea to build a theme park in California, which we know today as Disneyland. So he created a company of artists and Imagineers to help him design and then ultimately build Disneyland. And so Imagineering is the company, as it's called today, Walt Disney Imagineering, is responsible for coming up with the ideas and designing and building all of our parks and resorts around the world, our cruise ships, anything where our guests can go and have a physical experience with Disney.
We wanted to ask you about your early beginnings because you are a nuclear engineer. You have an incredible experience. Can you start by telling us how this technological landscape changed? Because you were also in the Navy and in NASA. So that's super interesting.
Yes, it's interesting, and technology has changed so much over the years. And I have a pretty good filter on my camera, but I'm really quite old, and so the technology landscape when I started my job in the Navy was quite different than it is today. So I remember when I finished college and I went into the Navy immediately after college, I had one computer class in college, and we actually used an IBM punch card machine to write lines of code in Fortran and Cobalt. I do believe I saw on one of your episodes, you went to a museum and you found one of those machines. So I guess that means in some form or fashion I belong in a museum, but that's the state of computer technology, for example, when I started in the Navy. So then I went into the Navy, I was a nuclear engineer for 6 years, and by the time I got out, desktop computers had come around. And you know, in the 6 short years I was there, I never used a desktop in the Navy. We didn't use desktop computers. I got to NASA, and my first day there, they said, well, you know, log on and download this program. And I sat embarrassed for an hour or so trying to figure out, log on? What exactly does that mean? And download and program. My start at NASA was not a very good start because I had skipped 6 years of technology, but technology changes so quickly. And my early years are things that you now find in museums. So things have changed a lot.
So in your experience, David, you have witnessed a significant technology shift through your career.
Yes.
Could you give us some examples and how this affected your work day to day?
Yeah, I remember when I started with Disney, and this is back in the early 90s, I was assigned to Paris. Here, we were building our first park here at Disneyland Paris. As part of Imagineering, we design and build ride systems and show elements, special effects, and media and music, and we also build buildings, because a lot of our attractions are inside buildings and, with streets and fountains and a lot of architecture and engineering. And back in the day, we used to, we have a home office in California. We had an office where we were building things in Paris, and we would literally ship drawings by plane. We'd roll drawings up, drawings that often were done by hand with pencils to get some of the details. We would take those drawings by hand and put them on a plane and send them from California to Paris and back and forth to allow both teams to work and have their input. You fast forward today and it's so easy. We have models and we're using all of the latest technology for design. We can have people working during the day in Paris and working at night in Glendale, in California, on the same design. We can even work on the design at the same time, having multiple people work on the design. We have models where you can, pull up these designs, whether it's the ride systems or the architecture, the engineering, the special effects, the projection cones. You can walk through these physical models in 3D. From the days when you used to ship things on planes or do fax overnight, the technology is just, it's rien à faire, as we say in French, quite an advancement. And I am old, but I'm not that old, so it hasn't been that long. Things change quickly.
How we can link the nuclear engineering part and the entertainment part of your career?
One thing about nuclear engineering is it's multidisciplinary, right? Because you can study nuclear engineering in school and study nuclear physics, but that's really a theory and a concept. But to make nuclear engineering work, it's a lot of mechanical systems, piping and valves and reactor cores and turbines and condensers and pumps. So you have to know a lot about mechanical engineering. This all creates electricity and uses a lot of electricity. We create electricity for the ship, we create water, it creates everything you need except food to sustain you on a ship. It's controlled by highly sophisticated controls programs for safety and for control of reactors. You have chemistry because the water has to be maintained at a certain pH and blah, 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 and radiology. So you have to be able to measure radiation to make sure there's no problems. So it's a mixture, multidisciplinary engineering discipline to operate nuclear reactors. Disney is the same way. We use technology for different reasons. For the Navy, the goal was to propel a ship and project the flag and serve the national interests, at sea and around the world. For Disney, our goal is to create emotions and to make people smile and to create memories that last a lifetime. We use engineering as a tool to that end. We don't use engineering for engineering's sake, and it's very multidisciplinary. We have 160 different disciplines at Imagineering, between all the different types of technical skills, engineering skills, artists and accountants, and you name it. It's very multidisciplinary. So there's that aspect of it, that it's really a collection of many, many different types of technology and art when it comes to Disney and the artistic side. One thing that is really fundamental also is that in nuclear power, whether it's in the Navy or the civilian world, safety is paramount. Without the assurance of absolute safety, no one would allow nuclear power plants to exist. And so safety is the number one concern. And while we don't talk about this much at Imagineering, we talk about storytelling and creating emotions and whatnot. Fundamental below everything and more important than anything is safety, because we invite people to come onto our attractions and our rides, and they absolutely must never doubt that they're safe. And that is a fundamental element of design. So that's a similar culture of safety in the nuclear Navy and at Disney.
The last time I went to Disneyland Paris, the Aerosmith ride.
Yes.
It's like
that roller coaster.
That thing shoots you like, I don't know how fast. You can tell me, because you designed those things.
I think it's been a long time since we did that. I think 45, 55 kilometers an hour. So but it's not the speed, it's the acceleration. Because speed is not fun, but acceleration certainly is.
When I met you and you told me that you designed all these things, and I'm like, wow, someone who knows about safety must.
And it was a system we used because we wanted that thrill. We wanted something people hadn't seen before, and the idea of that, that experience is that you're jetting off into a rock concert with Aerosmith. Most people expect to go up a lift when you go into an experience like that, but to launch someone straight across directly into a loop is totally unexpected, gets you totally disoriented, and just like you kind of want to feel at a rock concert, right? So you hear the music on board, and we actually got them to re-record the music to be in sync with the motion of the ride. So they re-recorded all of those songs. There were 5 different songs, and they re-recorded them to be in sync with the experience itself. So when you combine the physical feeling you have of motion and couple that with what you hear audibly, and then couple that with the lighting that you have, it creates an experience that you can't get anywhere else. And that's what we do, and that's what makes working at Imagineering quite fun, actually.
You really have fun at your work, no?
Yes, I think I have the best job in the whole world. Let's be honest. So, I feel very lucky.
Well, David, now talking about challenges and solutions, what are some of the biggest technical challenges you have faced in your projects or your career, and how have you addressed them?
I'll focus more on my latter career than my earlier career. The Navy, one of the big challenges is the environment you're in. Being at sea, Mother Nature can be kind and she can be cruel, and operating a highly sophisticated, technologically advanced system on the seas is quite a challenge. Some of the best times of my life, but nature can be quite difficult. If the Navy, the focus was on preparedness, being ready, being able to move at a moment's notice. At NASA, everything has to be perfect. You are putting something together that is going to be millions of miles away, and you can't send someone up there to fix it. If it breaks, you've wasted years of design and engineering and effort and labor. The culture at NASA was really about, you got to get it right. You got to look at every possible hazard analysis, everything that could possibly go wrong, and engineer it out. And where you can't engineer it out, you make it redundant, and maybe triply redundant, because there's no gas stations or repair stations once the thing launches. So it's a different culture there. With Disney, our challenge, it's a totally different type of challenge that we have. I've talked about safety, so I won't go back and talk about that. But, for Disney, our technology, it's a tool, it's not an objective. Sometimes we use technology that's been around hundreds and hundreds of years. You look up Pepper's ghost effect, you can Google that. And, the ability to give someone the image that they see a phantom, it's a technology that's hundreds of years old, but we still use it very effectively. Lighting has gotten better and things have gotten better, but it's a very effective tool. And sometimes we have to, invent technology. You probably rode Ratatouille when you were in Disneyland Paris. I think maybe even you did, Felipe.
Yeah.
Yeah. But, our goal was, we want you to feel like you've been reduced to the size of a rat, of one of the rats in the film Ratatouille, and that you're scurrying around the kitchen floor. You're scurrying around the size of a rat. And we didn't have a ride system that could do that. We didn't have a system that would allow us to do that. And it was important to kind of help you suspend your disbelief and kind of believe and to get into the story. So we actually looked at what technology exists in the market, and we found a company or several companies that use forklifts on the to actually take pallets from the warehouse to trucks, and from trucks to the warehouse, in these massive warehouses. And these things run autonomously. You program them on, go to pick up the crate at position A3 and take it to truck B7. Really great system. We're like, that's cool. It runs without a rail. It runs without any wires. You can program it, but we don't want to run pallets. We want to put people on board. And the company said, well, this is perfectly safe. You can walk across the floor and these things will never hit you. And it's like, no, we don't want to walk across the floor. We want to put people on the vehicle. We want to recreate this thing and beef it up a bit. And they said, we never thought about that, but let's give that a shot. We completely worked with the vendor to change completely the way their system was designed, using the core components so that we could use it for what we wanted to use it for. And it turned out to be just an amazing system, fun, and very flexible. But very, very complicated system. But again, the goal was not to have a complicated technical system. If we had a system that was hundreds of years old, we would have used it. But sometimes you can't find the technology you need to tell the story you want to tell in a convincing way. So
that comes the part of innovation.
That does. Mm-hmm. It's interesting. I talk a lot about us trying to, to solve problems. We have a problem we want to solve. We do sometimes we have a certain group within our company, within Imagineering, that gets to just play and say, what if? What could we do? They don't have a particular objective in mind. We created something a few years ago called a stunt-tronic. I think most people are familiar with our audio animatronics and characters we have in Pirates of the Caribbean and our classic Disney product. But we created something called a stunt-tronic, where our goal was to have this person look like Spider-Man flying through the air, doing spins and flips and all the things that Spider-Man does as he's jumping from one building to another. Could we do this? And by taking old things that have been known in physics for hundreds of years, and I think in this case, I hope I get this right, I think it's the conservation of rotational inertia. If I got that wrong, you'll edit this out. But to take that principle that everyone knows, if you're spinning in your chair and you put your arms out, you go slower, you pull your arms in, you go faster. That's the principle that everybody understands. But to be able to take that principle And with new technology of sensors and motors and Wi-Fi, we can take a simple bar and have this bar spin at a faster or slower rate as it's dropping, drop it through a little slot. So we can control these things. And if you take a couple of years of development, you can actually create an animated figure that can nip and tuck and flip and curl and spread back out. In real time, you can program him to do whatever tricks you want. And that started as a what if, could we really do something like this? And then we took that, the answer, which is yes. And then we were able to actually put that in our park, and it exists today at Disney's California Adventure. We were opening some Marvel attractions, and of course, Spider-Man is one of the most popular of the Marvel characters. What does every kid want to do? What is it every kid wants to be able to do? They want to be able to sling webs like Spider-Man, right? I mean, okay, it's not just the kids. You both want to do the same thing, and so do I. So it's something that, wouldn't it be cool if you could do that? And so our engineers, came up with a way to do that using technology, maybe using it in a way that it hadn't quite been used before. You're sitting in a vehicle next to three of your closest friends. Something has gone wrong, and these little animals are kind of wreaking havoc on the laboratory, and Spider-Man has to help gather all these little animals and save the laboratory. He needs your help. So you sit next to your friends, and you go on, and you see all these creatures, and you throw your arm out like Spider-Man, and voila, what you see is a web coming out of your hand and towards wherever you're aiming it. If your aim is any good, you might hit what you're going for. If it's not, you might not. But it uses technology of cameras that scan your face, keep track of your face, keep track of your eyes, where are you looking, follow your shoulder and your arm, where are you pointing. We can actually project onto the screen that you're looking at webs that are coming out of your hands towards whatever you're pointing at. And different colors for the different people, so you don't get confused as to whose webs are whose. You get points, so you can compete against your dad and your brothers and your your friends. And it's really, really convincing, and people love it. And the objective was to create some memory and create this cool thing that people want to be able to do with our characters. And so we set ourselves the task of, let's try to figure that out. And we did. And it's really cool.
As you mentioned, David, you use the technology as a tool. You create different technical advancement to use this robotics.
When people in general talk about robotics, they talk about machines that can perform work for people, like whether it's an assembly line for auto manufacturing or the like. For us, robots are used to simulate people or simulate characters or simulate some of our characters on our attractions or in our parks. I'm not at all sure we didn't invent robotics. I can't say that for a fact, but we've had audio animatronics in our parks since the very beginning back in the 1950s. So, but for us, it's about allowing you to suspend your disbelief. If you go to the Hall of Presidents at Walt Disney World, you see all the presidents there, and the goal is that you think they're, you suspend your disbelief. They're telling you a story. You don't want to be distracted by the fact that they're machines. You want to think that they're actually the real people there. Or if you're on an attraction, we all know the Small World dolls are animated figures. We all know they're dolls, but you don't want to think of them as robots. You think of them as dolls. The dolls that are telling a story, right? So the technology has improved incredibly because technology in general has improved. Back in the day, we had everything was done with hydraulics, with big hydraulic pistons and joints and valves, and sometimes it was pneumatic. And the components were big, and trying to fit these into a body the size of a human is not always that easy. Sometimes the valve is bigger than your elbow. You can't actually make your elbow move because the valve or the hinge is too big. So with time, technology has gotten smaller. We all know that, right? I mean, what's in your cell phone today would have taken up an entire building, 30 years ago. But technology has gotten smaller, including mechanical technology. We now use almost exclusively electrical systems. We have motors that are very small, that are very powerful. Sometimes we don't even need to have cables because we use Wi-Fi. I mean, so the technology itself has gotten better, which has allowed us to create things that are more realistic. And it's not just mechanical and electrical and control systems. It's even things like skin. Like, you look at our figures and, to create the face of someone to make it look like a person is very challenging. It's quite an art. And so even the advancement in materials, how long do these things last? How good do they look? How often do you have to repair them? How long do they keep their color? Can you use black light to project on that without ruining the fabric or the material? So a lot of the things that you wouldn't think about, that technology advances as well, which allows us, to take the technology and then create our own product to be something that's more convincing and allow us to even advance our own technology. Now we have characters that can walk around with no connection to anything. We have animated figures that can just walk through the park, which is kind of cool.
Those are amazing.
Yeah.
Talking about sustainability, how you promote, for example, energy efficiency, environmental responsibility.
Yeah. I mean, it's certainly a huge focus for the Walt Disney Company as well. I mean, I think, the Walt Disney Company is a very socially responsible. So we have set ourselves objectives and goals that, certainly far exceed the requirements in the United States, just trying to be good corporate citizens, because, we're members of this community as well and members of this world, and we want to set good precedent. So in all of our designs, we look at ways to, whether it's water or electricity or construction debris, we look at all the various and sundry ways that we can increase the sustainability. All of our lighting systems over the last few years have gone to LED. I mean, it's taken us, several years, but the consumption of electricity just from the light bulbs we have. I mean, you walk down Main Street and there's tens of thousands of light bulbs that illuminate that make it look so beautiful, but now they're all low energy consumption. And that's true through all of our parks around the world. Conserving water, making it such that for our water rides, maintenance, you drain them into a reservoir so you can pump the water back in. You don't just pump it to the drain and then fill it again with potable water. Collecting rainwater to fill our lakes. We create our own sewage treatment plants at our larger resorts so that we can use the wastewater for irrigation and for other things as it's allowed by the local authorities. Even on some of our ride systems, when you launch Rock and Roller Coaster, but you also have to stop it too, right? Mm-hmm. And when you brake, we can recuperate some of that energy in the braking. So instead of it just all dissipating the heat, we can actually recuperate some of that energy to go back into the grid. In Paris, we installed solar panels over our guest parking lot, and I think I'm correct when I say that it is the largest surface solar farm in Europe, and we're thinking about doing more. So I think as a company, environmentality, sustainability is at the forefront of everything we think about doing, and we're always challenging ourselves to be better and to be as good corporate citizens or social citizens as we can be.
And now, David, talking about the coming future, what technologies do you see will play a crucial role in the future of theme parks and the entertainment business?
I guess my point of view is, I don't know a lot about AI, but I'm quite intrigued by it. I don't know where it's going. I think it certainly has great potential, but we're starting to learn about it and how can we use it. Our bread and butter and what we do at Imagineering is about telling stories, allowing people to live stories, creating immersive environments, creating emotions, whether it's joy or shock or delight or awe. We rely strongly on humans to write those stories. Our own people write those stories. I'm convinced that our good writers are better than AI, and I'm convinced we will continue to be able to tell great stories. I'm optimistic about some of the other things in our process that AI may be able to help some of the technical aspects. So that's something that, it's changing so fast, but I'm optimistic that we're going to find ways to use that, and I'm sure that's not going to take very long. So that's probably the one that I think has the most opportunity to impact us all. Mm-hmm. So. And I'm probably not the only one that thinks that.
What is your advice for young engineers or the young people that is watching this interview? Send them a message.
First of all, I applaud you for being engineers because I think that's a great education in so many ways. It's a great way to spend time to get educated in something that you probably wouldn't learn yourself. So I applaud people that take up engineering. I think engineers tend to take two paths in their lives. I'll start by saying you need to be happy in what you're doing. We spend a third or half of our waking life at work doing a job. Pick something that makes you happy. For engineers, you tend to have a couple paths that you can take. Which one's going to make you happy? The world needs subject matter experts and engineers that spend their entire life doing engineering and getting smarter and getting more experience and being able to solve bigger problems and take on bigger challenges. So people that choose to spend their life as an engineer, I applaud, and I think that's, there's a satisfaction in that. And if that's what you want to do, then I say do it. I think other engineers aspire for something different, sometimes to to lead teams or to be in a leadership position or a management position, and to use their engineering background to help them in a different type of a job. For example, me, I'm an engineer from my training and my early formative years, but I don't do engineering anymore. But my engineering skills serve me quite well in my current job. But I chose at one point to go into a different direction with engineering, to be into management. So I think at some point you have to decide which of those things do you want to do, and then go which one's going to make you happy, and do it with gusto. Perfect. Then be curious. Always be curious.
Always be curious.
I think it's a great way to finish this interview. Thank you so much for your time.
It was a pleasure, David. It was a pleasure.
It was my pleasure. Thank you very much. Muchas gracias.
Muchas gracias, David.
You're welcome.
To all our friends, thank you so much for listening, and see you next time. And thank you, Felipe, also for being with us. Once again, David, thank you so much. See you very soon.